Hello everybody and welcome to Math with Corey. Today we're going to be looking at the power rule, okay? And we're going to look at a few examples, use the power rule, and hopefully by the end of the video you'll better understand the power rule and how to use it. Alright, so let's do it. Alright, so the first thing that I just want to do is look at this power rule. So basically if I have x raised to some number n, right, and I want to take the integral of that. So it's going to read integral x raised to the n dx. And dx just means that the variable that I'm using in this integral is x. So it's with respect to x, okay? Alright, so what I would do is take n, I'd add 1, and then I divide by n plus 1, right? That number that I just gotten. So again, x raised to the n plus 1 divided by that number n plus 1. Okay? And then one of the most important parts is that plus c. You don't want to forget that plus c. Okay? That's your constant of integration. Okay? Now the only exception to this power rule is for n equal to -1. Okay? And we'll look at what happens when n equals -1. Alright, but let's first look at a pretty standard example here. Okay, it's integral 4x raised to the 6 minus 2x cubed plus 7x minus 4. Okay, dx, okay, just means with respect to x. Okay, so the variable that I'm using in this integral is x. Okay, so how can I do this? Well, again, like I said before, I'm going to apply the power rule. Okay, now this might be a lot, but let's just take it I guess separately, right? Section by section, right? Starting from the top, okay? So if we look up here, okay, what I did here is I've separated basically each part of this integral. Now you don't have to do that, but I've done that for you just so that you can kind of easily see how we're going to be able to apply the power rule to each component of this integral or each part of this integral, okay? So starting off with the first part here, okay, 4x raised to the 6th. And again, I've written the integral sign and I've written dx, right, with respect to x. Okay, so just dealing with the first part here, right, don't get lost in everything else, okay? So the first thing that I'm going to do is say x raised to the 6 plus 1 over 6 plus 1. Well, why do I do that? Well, again, if we come back to the instructions of the power rule, rather, right? Basically, I take n, add 1, divide by that new number, right? Take 6, add 1, divide by that new number. So basically, I have 4x raised to the 7th over 7th, which is 4/7 x raised to the 7th. Okay, perfect. So the next part here, okay, says integral of -2x cubed dx. Now, it might be beneficial for you, right, to take out the constant, right? Here, I could have taken out that 4, right? I would have gotten the same answer, right? I could essentially take out the constant, okay, and just deal with my variable here, okay? So if I wanted to, right, I could take out this -2. But then I'm just using the power rule, right? So I'm adding 1, so I'm taking 3, adding 1, and then dividing by that new number, okay? 3 plus 1. So I have -2, right? I have that constant that I brought out, x raised to the 4th over 4, okay? And that's basically -1/2 x to the 4th, okay? All right. Here, right, for this part, I have 7x. Again, I could take out that 7, right, in front of the integral, or I could leave it in. Doesn't really matter. I'm going to get the same thing, okay? Basically, I'm taking x raised to the 1 plus 1 over 1 plus 1. Now, why is it 1 plus 1? Remember, when you have a variable like x, okay, there's, I guess, kind of an imaginary, not really an imaginary, but an understood one, right, up top. So when I have some variable, maybe it's y, maybe it's x, let's say it was z, okay, there's going to be a 1 up there. It's understood. And if there's an x, there's a 1. If there's a y, there's a 1, right? So in this case, right, there's a 1. So I'm doing the same exact thing, but I'm just saying that there is a 1 and it's understood, okay? So it's x1 raised to the 1 plus 1 over that new number, which is, again, 2. 1 plus 1 is 2. So I have 7x squared over 2, which is 7/2 x squared, okay? All right, good. So now the last part of this, which might be a little bit tricky. You might not really understand how this one works. Well, because there's no x, right? The variable isn't there. It's just a constant. Well, some people like to define it, right, kind of separately from the power rule. So if I had some constant k within the variable with respect to x, right, dx, this would equal kx plus constant of integration plus c. But essentially, okay, what I could say I have is this. I could say that it's the integral of kx raised to the 0, okay, dx, right? And anything raised to the 0 power is 1, so this is essentially saying k dx, right? So it's essentially saying the same thing, okay? So I've illustrated that here, but if you don't want to think about it like that, if you like to just think about it as it's the integral of some constant, well, anytime it's an integral of some constant, I'm just going to multiply the variable by the constant by the variable, and then add my constant of integration. That's completely fine, and that's okay. So every time you come across some integral of a constant, you could just think that, okay, I take my constant k times x plus c. Okay, fine. Or you could think about it like this. As you progress through mathematics, you're probably just gonna, it's gonna become second nature. So you're not really gonna be thinking about it like this. But I've just put it in here for now. Okay, so it'd be x raised to the 0, right, which would be 1. Okay, but I'm going to add 1, right, just as my power rule says. So x to the 0 plus 1 over 0 plus 1 is going to be negative 4 times x. Okay, because x raised to the first power is really just x, just like we discussed here. So it's going to be negative 4x over 1. Anything over 1 is itself, so negative 4x, and then plus c. Now, what I want you to see, okay, is that I could have said plus c for each and every one of these. So after I integrated this one, I could have said plus c. And after I integrated this one, I could have said plus c. And then this one plus c, and then this one plus c. And there would be a lot of plus c's. What I want you to understand is that if I pretty much added all those constants together, I'd get another constant, something that I didn't know, some constant that I didn't know. So I could have said plus c, plus c, plus c, plus c, plus c, all the way to the end, okay? Or I could have just saved a plus c for the end, right? Which kind of represents a constant that has multiple constants added up together. But again, it doesn't really matter because that constant, I don't know what it is, right? So if I had 6 unknown constants or 1 unknown constant, I still don't know what it is. So it shouldn't matter that much. Now, it's important to have this constant because if we think about it, right, if we took the derivative, we should get back to our original, right, our original function here. But let's say this was a constant. If I take the derivative of a constant, it's going to be 0, okay? So if I actually work that way, right, it's gonna still work, right? So the constant of integration is important and it checks out, right? There's no really kind of fishy things going on there, right? Again, if I took the derivative, I'd get right back here, a-okay, all right? So now let's look at what happens when n equals -1. All right, so real quickly, we'll discuss what happens when n equals -1. So if I had the integral of x raised to the -1, so again, in this case, n equals -1 dx, what I'd get is what we call the natural logarithm of x, and then again, plus c. Of course, we always have that constant of integration, okay? So ln of x plus c. Okay, so that's just one of the kind of exceptions to the power rule, okay? And why would, well, if we didn't think about it like this and we actually applied the power rule, the only problem would be this, okay? We'd have x raised to the 0 power over 0, because -1 plus 1 is, of course, 0. And we know we can't have a 0 in the denominator, right? It's going to be undefined. So we're going to call it the natural logarithm of x, and then we're going to add our constant of integration. Just one thing I want you to see is, okay, if x to the -1 is basically 1 over x, right? If we bring that to the denominator, it's going to be positive, so it's going to be 1 over x. Okay, and in this case, I had 1 over 5 times x, okay? That's basically like saying 1/5 times 1 over x, okay? Or I can take out that constant, okay, like I had discussed before, and it'd be 1/5 times the integral 1 over x dx, okay? Which equals 1/5 times ln of x plus c, okay? Which I can just write as 1/5 ln of x plus c. okay? And I want you to get kind of comfortable with this idea, right? Because you might be saying, well, this is supposed to be 1/5 times c. Well, it wouldn't really matter, right? It would take this unknown constant, this constant that I don't know what it is, right? I'd be multiplying it by a fifth, and then at the end of it, I still wouldn't know what it is. So we'll just call it some constant c, okay? So that's what happens when n equals -1. Let's take a look at some other examples. All right, so what if we had some examples like this, right? So here, I'll just rewrite it here, right? So for this one, right, I have the integral of the square root of z dz, okay? And basically, I want to rewrite these, right? I want to rewrite these so I have my variable raised to some number, okay? So I want this to be the integral of z raised to the 1/2 dz. Okay, because remember the square root of z, okay, we'll say, is the same thing as saying z raised to the 1/2, okay? And in doing that, right, it's going to be much easier to see how I can use my power rule, right? So I'll just take 1/2, I'll add 1, okay, and then I'll divide by 1/2 plus 1, okay? Same thing with this. So I have this integral, and remember the rule, right? It's, let's say we had the square root of x, okay? Well, there's a 1 here, right? And there's a 2 here, okay? So it's going to be the power over the index. So I can rewrite this as the power, which is 1, over 2. Same thing here. The power here is 3 over the index, which is 2, okay? So it's going to be integral z raised to the 3/2. Okay, and same thing here. It's going to be x raised to the 2/3, right? Because it's going to be the power over the index, okay? And here, okay, it's going to be the power, which is 1, over the index, which is 3. So it's going to be integral w raised to the 1/3 dw, okay? And I've used different variables. I've used z, x, w, just to show you that it really doesn't matter what my variable is, okay? Just make sure, okay, if the problem that you're working on introduces an integral with respect to x, that your answer is with respect to x, right? Don't just change your variable, as you're progressing through the problem, right? In the middle of doing the problem, don't, have an x and then switch to z all of a sudden, right? We want to keep that consistent, okay? But if we look at this in particular, right, I'll work this one out here. So again, we said we can rewrite this as w raised to the 1/3. So what I did here is I took 1/3, I added 1, so again, right, same process, add 1, and then divide by 1/3 plus 1. Well, 1/3 plus 1, that's 4/3, okay? And if I divide by 4/3, okay, that is the same thing as multiplying by the reciprocal, right? So 3/4, w 4/3, right? And that's just a rule that we hopefully should know, right? But basically when dividing by a fraction, I could just multiply by its reciprocal, okay? So if you come across something, ones that look like this, okay, I would rewrite it, okay, and then apply the power rule as usual, okay? I do have a problem here for anyone that would like to try. I'll give the answer right after, but if you want to give that one a try, it's a little bit tricky, a little bit different. All right, so hopefully you've tried it by now, and if you've tried it, hopefully you got something that looks like this, okay? So basically what I did, okay, I just rewrote the integral, right? So it's going to be 1 over x raised to the 1st, okay? X raised to the 1/2. Again, square root of x is the same thing as x raised to the 1/2 dx. Okay. So then, okay, x raised to the 1st power times x raised to the 1/2 power is 1 over, we're going to say x to the 3/2, okay? Then what I can do is I could bring this, okay, to the top. So it's going to be the integral of x raised to the -3/2 dx. Then I'm going to apply the power rule as usual, right? I'm going to say that it's -3/2 plus 1 over that number, which is -3/2 plus 1, right? Plus my constant of integration. So one thing I just want to make sure that you can, that you see, right? Anytime, right? Anytime I get rid of my integral sign, right? That means I'm done with my integration, right? this is all just like simplifying basically. But once I'm done with that integration, I need that plus c. Okay, so maybe you're working on a problem. Once your teacher sees that you don't have this integral sign, that means the integration is over. Okay, and if the integration is over, make sure you have that plus c. Okay, of course you won't need the plus c if you have limits to your integral, right? And that's you know, this is an indefinite integral. But once you get rid of this, right, think about putting that plus c. Okay, all right, so then from here, right, negative 3/2 plus 1 is negative 1/2. Okay, so then I can divide by that new number. But remember what I said, when I divide by a fraction, I can multiply by its reciprocal. So it's just going to be negative 2 times 1 over x raised to the 1/2 plus c plus c. Okay, so then I could just bring that negative 2 up top. So it's going to be negative 2 over, and I can rewrite this as the square root of x. Okay, and then plus c. All right, so just one thing that I want to make note of, right? I could have left it basically here, right? I could have left it here, but the only thing here is usually in math, right, you don't want a some variable raised to a negative number, right? You want it positive, right? So in this case, I was able to make it positive, and not only was I able to make it positive, right, x raised to the 1/2 is the same thing as saying the square root of x, right? So just some things to kind of keep note of. And the last thing that I wanted to kind of show was if we had something that looked like this, right? So we had basically, I guess you could say, two factors of this, okay? But basically what I would want to do here, okay, I'm going to apply the power rule, right? But just not at first, right? So I want to do some simplifying before I do that. So what I'm going to do is just multiply this and this together, right? And I'm going to get 3x raised to the second plus x minus 2, okay? The integral of that with respect to x. Okay, and then use a power rule as normal, right? So x raised to the third over 3, that's going to be x cubed, plus x squared over 2 minus 2x plus my constant of integration, okay? So a lot of things that we've seen, like the different problems that we've seen, basically you just want to simplify, right? Sometimes simplifying is the first step that you need to take, okay, before you go on to using the power rule or maybe any other method that you're going to be learning in the near future, right? So basically simplifying could be a very important tool, okay, that we need to use, or something that we need to do before, okay, we get into using these strategies and you know, rules and stuff like that. If you guys have any questions, please leave it in the comments below. I'm here to help. Thank you for watching.